Hi there, Charter family. This is Mrs. Boyd, Mrs. Boyd's Math Room. Thank you for joining me to talk about functions. Let's put the fun in functions. We learned about relations and how we can display how points, either discrete or continuous, are connected. Just to review, discrete is if they're just a rando assortment of points. Continuous is the line. Well, we're going to take those relations and see if they're functions or not. First thing we're going to look at is a table. Well, you can see here that we have a table. All of the x values go to different y's. So -2 is only listed once, 0 is only listed once, 1 is only listed once, 2 only listed once. That makes it a function. That means if we're going to put it in words, each x value is paired with one y value. Okay, that is a yes, a function. No, a function is where we'll have x values and some are repeated, like -1 and -1. When they're repeated, -1 can either be 2 or 1. That means it's not a function. So not a function, the x value of -1 is paired with 2 y values, 2 and 1. Okay, so yes, a function, every x value has a different y. No, a function if x is repeated. Next, we've got a mapping. Let's put some example points in here. If we've got a domain of -2, 0, 1, and 2, and a range of 2, 3, -1, and 4, and each of these x values goes to a different y value, this is a function. That says that each x value is mapped onto one y value. Okay, yes, a function. Every x value only has one arrow coming from it. Let's try another set of points. Say our domain's -3, -1, and 2, and the range is -2, 2, 1, -3. We'll have arrows. 3 goes to -2, -1 goes to 2, -1 goes to 1, and 2 goes to -3. This is not a function, and it's because of this right here. That's telling us the x value of -1 maps onto 2 y values, 2 and 1, just like above. So no, yes function, every x value has one arrow coming from it. No function, any of the x values have more than one arrow, okay? Last but not least, we're going to just stick with those same points, but now we're going to do a graphing. So we'll do -2, 2, 0, 3, 1, -1, 2, 4. So we're going to use what's called the vertical line test. The vertical line test says that we can draw a vertical line through any parts of our relation, and it should only pass through one point in the relation. So let's test it out. Here's that. That's only 1 point. That one goes through 1 point. That one does. And that one does. So this is yes, a relation, because it passes the vertical line test. We could also have the same points that we had above. That's -3, -2, -1, 2, -1, 1, and 2, -3. Oh, that's not right. All right, so 2, -3. There we go. So we're going to do the same thing. We're going to draw these same lines vertically through each point in our relation. So that one only hits 1. Well, that one is the problem. That one goes through 2. So anytime our vertical lines go through 2 points, the relation, is not a function. So this is no because it does not pass the vertical line test. Okay? Simple enough, I think. Now let's talk a little bit about some notation. You've probably seen already on some problems that we've done function notation. That looks like this. So if we had an equation, y equals 3x minus 4, we could also write it in function notation. So we're going to write f of x, and that, like I said, reads as f of x. The f is just a label. So this is now the f equation with a variable of x. So f of x equals 3x minus 4. It's the same equation, and f of x essentially just means y. Like I said, it's just a label, so that when we're given several equations, we know which one we're talking about, like in this case. So we've got evaluate if f of x equals 3x minus 4 and g of x equals 2x squared minus 3x. Well, f here tells us that we want to access the f equation. And the 2 here says we're going to take x and plug in 2 everywhere there's an x. So let's do that. F of 2 equals 3 times 2 minus 4. Well, f of 2, if we simplify, 3 times 2 is 6, and that's minus 4. And lastly, f of 2 equals 6 minus 4 is 2. So f of 2 equals 2. Same idea for g of 4. We're looking for the g equation, and everywhere there's an x, we're going to put a 4. So here and here. So g of 4 is 2 times 4 squared minus 3 times 4. Well, let's do some simplifying. G of 4 is 2 times 16 minus 12. G of 4 also is 32 minus 12. So that means G of 4 is 20. Same idea, but now we've got a negative number, f of negative 3. Well, that's 3 times negative 3 minus 4. That means f of negative 3 is negative 9 minus 4. And f of negative 3 is negative 13. G of negative 4 this time. So 2 times negative 4 squared minus 3 times negative 4. G of negative 4 then is 2 times 16 plus 12. Negative 3 times negative 4 is plus 12. Well, G of negative 4 is 32 plus 12 this time. So G of negative 4 is 44. Keep it on. We have f of 2x. Don't let this throw you. We use the f equation, and we put 2x everywhere there's an x. So f of 2x is going to equal 3 times 2x minus 4. In other words, f of 2x is 6x minus 4. Same idea. It is the g equation, but we're going to put 2x everywhere there's an x. So I have 3 times 2x. Oh, just kidding. Oh. Sorry about that. Looking at the wrong thing. So 2 times 2x squared minus 3 times 2x. Well, let's simplify. We have 2, g of 2x equals 2x squared is 4x squared. Trust me, we haven't really done that yet. Minus 6x. G of 2x is 8x squared minus 6x. And that's it. As good as it gets. Last but not least, we've got f of -1 plus 5. That means we're going to take the f equation and plug in -1 and then add 5 to it. So we have 3 times -1 minus 4 plus 5 on the end. F of -1 plus 5 is -3 minus 4 plus 5. So f of -1 plus 5 is -7, -2. Same idea, g of -1 plus 5. We take g of -1 and add 5 onto the end. So 2 times -1 squared minus 3 times -1 plus 5. Let's simplify a bit. 2 times 1 plus 3 plus 5. G of -1 plus 5 is 2 plus 3 plus 5, which is 10. I hope these make all sorts of sense to you. I hope you're getting a hang of what we're doing with functions and what it means to be a function. And I hope you get to see me soon.